Hello everyone. So today we're gonna go over some basic networking concepts. So as you know, when you get a internet connection, let's say from your uh, Bell Rogers, which is like your internet service provider, so you usually get a router, right? So this, when you turn on the router and for it to function, it needs some information from your ISP. So the main information it will need is like the IP address, which we call the public IP address. So why do we need this public IP address? So this is how other computers would know to reach you basically. So let's say if you access a website, so the website will know how to get to reach you based on this IP address, right? So the thing is, though, there's a couple more information that you get from your ISP, and how is this information provided, right? So there's a mechanism this happens. So usually there's something called dynamic host configuration protocol. So basically, there's a DHCP. It's called DHCP for short, and there will be a server usually running in your ISP, and correspondingly, there will be a client running in a router, right? So this client will then contact the DHCP server. It'll basically send out a DHCP discover message, and this message goes to your ISP and reaches your server, and the server responds with this public IP address information. And actually, it actually um, gives a couple more information, like I mentioned, and which is basically the DHCP lease file. So, and the lease file will have the public IP as I mentioned. And there is also like sometimes actually like it'll have a lease timeout value. So that's how long you have this IP address valid, right? Based on the parameters provided by the server. So usually it has a time limit. It's not forever, right? So the server will provide you an IP address for a set limit of time, and after that you have to get a new lease from the server. So that's another parameter. And there's another very important parameter that you receive, right? So before I get into that, so what happens behind here when you have a device connecting to your router, right? So let's say there's a PC that you're connecting. So usually, if you notice, it does not get the IP address your router has. It has its own IP address, which is provided by the router, right? So where does this IP address come in? Usually, if you notice, it's in a weird subnet. It's a 192.168 subnet, and this address, if you notice, it's not a public address. You can't reach. There's no machine out there with this subnet that you can reach, right? So this is reserved for local hosts, pretty much. So what happens is the router will have its own DHCP server, which the clients basically, which is a PC, which will have a DHCP client running, which will contact the DHCP server in your router to get its own IP address, right? So this IP address is controlled by this router, so it only cares about the devices behind this router, right? So it just makes sure it does not have the same IP, and it provides a lease file, and also provides some more information, like I mentioned. So we'll get to that. So this is how you see how you have your client and your router and your ISP, and how you get your IP address. So now what's we move on to is there's something more you get in your DHCP lease file, which is the DNS server information. So DNS is basically domain name servers. So what is domain name? Basically, domain name resolution is when, let's say, you type a website name, right? Usually when you type this, the computer does not really understand this, right? It's not an address. So when you type this in the browser, or try to ping it or something, so it does not know how to get to that machine. So how does this work? So what happens is usually there's a DNS server, right? So there's a DNS server in your ISP, right? And there's like I said, domain name resolution. And there will be a DNS client. No, actually not a client. There will actually be a DNS server in your router also, and I'll get to that for a point. So let's go from a PC, right? So let's say you're trying to go to google.com. So what's going to happen is it's going to contact the DNS server in your router, right? It's going to be like, who's google.com, tell me. So the DNS server in your router, well, why do you have a DNS server here? So basically you have one here because it checks if there's any other local host. So let's say you have another PC, right? And you name it PC2. So if the host name of that is PC2, when you set your host name, like device name in your Windows, and when the DHCP client requests its lease, it actually requests for the host name, with it. So what it tells is DHCP server, please give me this host name for my machine. So what happens is when that happens, the DHCP server will tell the DNS server, okay, I've added this machine, I've given it this IP, and this is its host name. Add it to your DNS server. So now in this DNS server, it'll have PC is equal to 192. Let's say we give it an IP address. Let's 2.1. So when you ping PC from, let's say PC2, when you try to ping PC or reach PC, if there's an Apache server, you can just type PC and it'll go into that IP address. Basically, the the there'll be a DNS request going into the DNS server in your router, and it does not need to go outside because locally it finds PC and it says, okay, PC is locally here at 192 network, and you go and contact this IP directly. So now what happens? Let's say you want to reach Google from PC2, right? So now you have to go outside because this server usually does not know what machine Google.com is, right? And Google will change it and probably changes every second. So Google.com will be one IP address at one point, but then it's a different IP address at a different point because they deal with a lot of traffic, right? So they have load balancers and many complex network routing going. In this case, what's going to happen is you're going to have something called DNS forwarders configured. So this is where the information I was saying, the DNS servers that you get from the ISP during the DHCP negotiation. So in this, it's not a server, it'll be the forwarders. So you'll have something called DNS forwarders, which are basically the servers, DNS servers provided by your ISP, right, um, 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 to your router. So basically, what will happen is when PC2 requests the DNS server for the information of what machine Google is, it's gonna check. It's gonna check locally if there's Google, if there's a machine Google.com, Google locally. If there's no machine locally, then it's gonna check its forwarders and send a request to the DNS server in your ISP, and your ISP will have its own forwarders, so it will eventually reach the Google, servers. So it'll configure many public forwarders itself. So that's how we'll eventually reach and resolve what google.com is, and it'll send you back that IP address, and the machine can then send packets addressed to that IP address. So now there's something going on here, right? So like I mentioned, this IP address is hidden, right? It's behind this router, so you can't reach it from outside. So let's say you have a mobile phone, right? Mobile with LTE, and you're accessing it out from a different network completely, and you're trying to reach this PC. The thing is, so there's two things. Let's say a mobile, and let's say one use case there's a server, right? So in this case, this is, let's say, the Google server or whatever. So you get your domain name resolved, and then you send the packet address to that server. So what happens is it's going to go through your router, through your ISP, and ISP is going to send that to the server. So this way is okay. So if you, from your PC, if you send a packet address to any IP address on the outside, it'll go, right? There's no issue. But what happens when the server tries to contact, let's say if the server wants to contact this machine, how is it possible? How is it possible to go the reverse, right? So if this server wants to go, it only knows the public IP usually. Like you can't, even if you provide this IP address, there's no way to reach it publicly. Like the only exposed IP address in this network, like pretty much like it's quarantined, right? The whole network I can put in a box. So it's quarantined from your home network. So there's no way to reach this IP address from the outside. So the only way is to go through your router, which has an IP address. That's right. So when your server, let's say, initiates a connection, and it's going to go to your IP, public IP address of the router, it's going to reach your router. But then the router, let's say you initiated the connection this way, the router would not know which machine to send it, right? So how does this work? That's where the next aspect of networking comes, and that's network address translation, or NAT. So I'll just put a box in your. There's a NAT basically. So now I'll say go further. It's a NAT table. Basically, it's just a table. So what happens is when you contact a web server outside. Let's go the other way. So when you do this kind of, let's say, an external IP outside, right, a web server. So it's gonna send the packets. It's gonna go through here, but what's gonna happen is your router is gonna store that information in a table. So it's gonna say like, okay, this PC with this IP, try to contact this server, let's say with its own public IP 172.168 or something. That's right. So in that sub, so this NAT table is going to store that server IP address and say, okay, 192 send packets to 178. So what happens is now when there's a response, let's say HTTP, right? The HTTP response is going to arrive in your router, and it's going to look up the NAT table. So in the NAT table, it's going to find the entry for, oh, okay, this PC had contacted this server before, so I'm going to let this packet go to this guy. So that's how you're able to access websites pretty much because of the NAT in your router. If there's no NAT, you won't be able to access anything because the reverse pathway will be blocked. Because there's no way to know which PC to send it back, right? Because you can send it back to public IP but not behind your router. So yeah, that's your NAT. So this is why the main reason I went over this is very important because if you want to host your own web server or servers, let's say in a PC here, right? Let's say I have my own website hosted in PC2, right? You want to build your own products. You don't want to use Azure, AWS, pay for anything, right? So if you have your own web server here or website running in a PC, usually the HTTP is port 80. So usually when you type something in the website, it's actually resolves to 80, right? So that's your port 80. That's HTTP. HTTPS, of course, runs in 443, I believe. So you have this website running here. So now let's say the problem is from this mobile, as well, this mobile. Now this client wants to reach your website, right? So now what the problem is, you're gonna have is because you're not gonna reach him, right? You don't know his IP. You don't know someone who's gonna open the web browser and type your website. So the idea is, so when he contacts you, his packet's gonna arrive here. There's not gonna be a NAT entry for your web server, right? So the router is naturally gonna drop the packet. So how do you host your own website then? So there's a couple of ways. The main way usually is port forwarding, which is really easy because you can log into your router at home, and I can show you that in a follow-up video how to host your own website from your home. So you can open a port in your router and basically say whatever packets that come to the router at port 80, send it to this PC. Right? So that you cannot. That's not in the NAT table. So the idea is, so if any mobile comes, any packet comes from the mobile here, there's no entry in the NAT table. It's gonna port forward it to this PC, and this PC will get that packet now, and this is gonna send it back to that public IP or the IP address of your device there. So it's gonna pass through there. So now basically that's NAT port forwarding, and I will show you that in the follow-up video, like I mentioned. So I think that's good for now. I will release more videos um, to get you knowledge to build your own web services and products. Yeah, thank you for listening.